Welcome back to Machine Learning Applied. This is the last segment of the mini-series on multimedia generative AI, image generation, video generation, and stringing them all together. This is the most important episode, and it's the one that I'm going to be linking out on socials because it's very practical. It teaches you how to make a movie or an ad using the tools that we've discussed. The last two episodes had sample workflows, total theoreticals. This episode has 3 real workflows used by professionals in the wild. In fact, I might go back and remove the sample workflows from the previous episodes. I think they were more distracting than helpful. If you land on this episode first and you haven't listened to the last 2 episodes, those are what are these tools and how do they compare? So you only need to listen to them if you don't know what the value prop difference is between GPT-4o versus Midjourney or VO3 versus Sora. And especially if you don't know much about the Stable Diffusion ecosystem, because Workflow 3 will be Stable Diffusion heavy, and you'll want some background information on Stable Diffusion. So prompt engineering, my friends, I'm afraid I had to exclude it. The content of this episode got too long. And there's something in my DNA that requires miniseries to be in 3s, as well as I don't want to dilute this podcast series too much. The whole series about AI and machine learning. I don't want to pigeonhole multimedia for too long. So I had to exclude it. I'm so sorry. I may do a super episode on prompt engineering across various domains in the future. This would include, obviously, image and video generation, because prompt engineering for image and video gen is the most important. Where prompt engineering is applicable is very nuanced and specific, the types of words and flags and parameters you use. But I would also maybe include prompt engineering for vibe coding and general chat. In the meantime, though, I put the prompt engineering guide on my website's show notes. So go to ocdeval.com/MLG, click this episode, and you can find the prompt guide near the top. Click to expand it, and you can download it as a PDF or an EPUB for your Kindle. I'll also have a few other long readable or downloadable guides there because there's so much background material for this episode. These will include, number 1, a big guide on audio, music, text-to-speech, and sound effects tools, because this episode's just going to do a very fast speed run on the audio tools. And number 2, a breakout guide on open source text-to-speech tools specifically, because there's a lot out there and it's moving really fast. And many of these are nearly as good as 11 Labs in quality. Number 3 will be a super guide on prompt engineering for image and video generation, like I said. And then, of course, the body of the show notes will be the workflows of this episode. So if you want deep reading material around this episode or relevant material outside of this episode, then go to the website's show notes, not the podcatcher show notes. Go to ocdeval.com. Also in the show notes will be links to leaderboards for all of these tools: video generators, image generators, text-to-speech tools. Leaderboards do A/B testing from voters, and they capture the quality of tools. So they're a ranked list of the best quality image generators or the best quality video generators or text-to-speech. And this is a good place to start for choosing your weapon. Of course, quality isn't the whole picture, so tooling matters, as you'll see in the workflows of this episode. But that's a great place to just get a lay of the land of the quality of the image and video and text-to-speech tools available. Okay, before we talk workflows, let's talk audio. So for music, you're going to choose based on your goal. For a complete, ready-to-use song, for content like a YouTube video, use Suno. Suno, the AI music generator. And then for high quality audio components and inspiration to edit in a professional audio program, use Udio, UDIO. Now, both of those tools are very good at generating songs, generative music from scratch. It's not to say that Udio doesn't give you a great usable song out the gate. It's just that if we had to differentiate the two, because both are very popularly used in the wild, both Suno and Udio are very popular music generators. If we had to draw a line between them, that line might look like using Suno to get something right out the gate. And the analogy would be like VO3, where you get everything all you want, one-shot prompt, easy peasy. and using Udio if you plan to be a little bit more hands-on, more long-term thinking and music editing with your music editor with your DAW of choice. And that would be akin to Kling or Runway Gen 4 per the last episode. So an easy way to remember that is Suno has fewer syllables in the word. So there's fewer steps involved for go-to-market music. Podcasters who want to add sound effects and narration in the same tool should use 11 Labs integrated sound effects generator. 11 Labs, the best in class text-to-speech tool on the market, also has sound effects integrated. So if you want both sound effects and text-to-speech, use 11 Labs. But game developers and filmmakers who need a larger library of unique licensed assets for a component-based workflow, they should use a specialized tool. There's one out there called Sound Effects Engine or SFX Engine. Do a little bit of research, but there's sound effects AI generators that give you a bit more control. For voice generation, that's text-to-speech, 11 Labs is the best. It is the best. 11 Labs wins. The best for pure realism, but different workflows may require different tools. So Murf, MURF.ai, offers an all-in-one studio for marketing teams. And Play.ht has a low latency API for enterprise developers who need real-time text-to-speech. And again, go to my show notes to get the deep dive on all of this if you need more information here. For open source local text-to-speech, there's a bunch of models out there, a bunch of models and toolkits and SDKs and UIs and wrappers and stuff. It is a giant space of its own. And many of them are almost as good as 11 Labs. In particular, Kokoro. I tried this recently. I love text-to-speech. I actually use it to generate audio that I use for my research for these podcast episodes rather than listening to podcasts. So I'll generate deep research reports or I'll text-to-speech existing EPUB or books. And the one I like the most is Kokoro, Kokoro. It just sounds phenomenal. It sounds almost as good as 11 Labs in my opinion. There's also Style TTS 2, and that achieves human level quality and is best for generating natural speech without a reference voice. And there's voice cloning with very minimal audio input. One's called Koqui, COQUI. And the model it uses XTTS v2. And for applications that need high speed, where speed is the most important, then Piper TTS is a really lightweight and popular choice. And these open source voice generators, you're likely to use in your Stable Diffusion ComfyUI end-to-end workflow, either during experimentation, so you're not breaking the bank on 11 Labs credit expenditure, or in the final product, if you find that one of these open source alternatives is good enough for your purposes. So the local installation tools, similar to the Stable Diffusion model, similar to the Stable Diffusion model and ecosystem, are great for stringing together high throughput, low latency, and still very good quality, but also very hands-on, highly technical workflows. Again, go to my website's show notes for a deep research report on the open source offerings. Okay, that's the speedrun on audio. Now let's talk workflows. Now, this episode gives 3 core workflows based on personas. What are you doing? What's your angle here? What's your professional role? So workflow 1 is the beginner, a social media campaign or a growth marketing or ads, or you're just a one-person band, low-budget startup. You want quick but good results. Workflow 2 is intermediate. You're an indie short film maker or an enthusiast, and you want serious results. And workflow 3 is a freaking AAA multi-million-dollar budget box office movie. You work in Hollywood, and you want to stay ahead of AI in this very scary time. This stuff is your DNA, and you have every intention to be highly technical. But before we go into those 3 workflows, let's quickly talk workflow 0. Workflow 0, you want instantaneous results. This is not your field. You have no intention of wiring things together, multiple tools, and learning these complex systems. So either you get a kick out of AI videos, these are people who are blasting TikTok with Bigfoot vlogs or glass-cutting ASMR videos, or it's part of your business, but you're really, really tight on budget and time. Workflow zero. So firstly, VO3. Google VO3 has everything you need all in one. And with the Flow tool, you can do top tier text to video with phenomenal prompt adherence. You can use ingredients and frames to video and extend clips and generate frames first with Imagen 4, all built into Flow. It has voice. It has perfect lip syncing. It even has music. Google has a music tool called Lyria to compete with Udio and Suno. It's not as good as Udio or Suno currently, but I'm sure it will get there. I'm not sure if you can prompt music via Lyria into a clip or if it's a post-production thing in Flow or what. I haven't seen the feature in my usage yet. Now, do not be fooled. VO is not a Bigfoot and ASMR toy. I have seen actual advertisements built with VO, literal, real-world advertisements. I'm not talking example advertisements for funsies on Reddit. I've actually seen ads built with VO3, like on the internet, on TV. One of these was a real estate ad by a married couple. I mean, I can't imagine they were breaking out Mid-Journey prompt engineering piped to lip syncing with Kling. So don't underestimate VO3, okay? VO3 is your starting point without question. In fact, before you do anything, before you even listen to this episode, VO3 is your starting point. The rest of this episode is really all about more advanced, sophisticated tooling where VO3 falls short. Now, still in Workflow Zero, if you need something more corporate, more businessy, not just a video clip action scene with characters, you want branding, text, color schemes, marketing material, and a bit more end-to-end control than VO for social media marketing and advertising, but not so much control as the workflows we'll talk about next, then what you're looking for is an aggregator, a generative AI aggregator. So what many of these tools do is they allow you to choose among the different image generators like GPT-4o, Mid-Journey, Imagen 4, etc., and the video generators like VO3, Sora, Mid-Journey, etc., and string them together on a timeline. Many of these have hand-holding tools for consistency and outpainting between the image and video steps for resolution conformity, and then post-production tools for branding and so forth. Popular tools in this category include Envato, E-N-V-A-T-O, OpenArt, Remade, InVideo, I-N-V-I-D-E-O, Canva, actually. Canva is starting to add a lot of AI tooling way outside of their original business focus. And Pika Labs, P-I-K-A. Pika didn't come up much in my research for the head-to-head pure video generation of the last episode in terms of quality. That surprised me because they're a competitor in generating AI videos. They used to come up a lot online. I don't know if they're just temporarily behind on video generation or if they're sort of moving towards these sort of heavy end-to-end workflows here, kind of per this Workflow Zero topic. But give them a gander. So I won't really get into these tools. These are wrapper tools. There's a lot of Johnny-come-lately startups, and it's only going to expand depending, I guess, on how much Flow with VO3 ends up covering all these bases and squashing the competition. And they're kind of expensive for what they do in terms of credit to generation value, as opposed to using the raw tools. And I think it's valuable to learn the core tools, frankly. Also, you're listening to Machine Learning Guide, a podcast about AI, so I think it's safe to say that you're here because you have some skin in the AI game. But if this is a route that interests you, you'll want to do your own research there. So start your research with OpenArt and Canva, I think would be two good tools to start your Google journey. Okay, Let's get into the workflows. Okay, so 3 workflows. The beginner or the prosumer, a social media manager or content creator who needs to produce high impact, short form content, for example, for TikTok or an advertisement or YouTube shorts, quickly and easily. Number 2, the independent filmmaker, a storyteller focused on creating short films with consistent characters and a cinematic feel, who is willing to handle moderate technical complexity. And then number 3, the professional studio, a visual effects artist or a production team that needs absolute control over the final image, actor likeness, and integration with standard VFX pipelines. Workflow 1, the prosumer workflow, creating a viral video with VO3 and high quality chaining. Chaining as in prompt adherence and character consistency. Okay, this workflow is for social media managers and marketers who need to produce high volume, visually engaging short form content for platforms like TikTok, Instagram Reels, and YouTube Shorts. The main goals are speed and brand consistency. The problem is that VO3, while it generates really high quality 8-second clips with integrated ambient audio and voice, it has a weak native extend feature. This feature uses the lower quality VO2 model, causing a noticeable drop in visual consistency. So if you create an initial clip in VO3, an 8-second clip, either text to video or first frame to video, you'll be able to use the VO3 quality model and you'll get a very high quality clip. You cannot do this currently, July 13th, 2025, with the ingredients to frame feature or the first and last frame feature or the extend clip feature. If you try that, it will downgrade you to VO2, which is a very bad quality generator. So the high quality chaining methods we'll discuss avoid this by manually connecting high quality clips that you generate each clip independently. So here's the tool chain. Image generation. You're going to use GPT-4o, the API, or platform.openai.com, which is a website wrapper of the API, not chatgpt.com. We choose GPT-4o for its excellent prompt adherence and text rendering ability. It delivers the specific visual you asked for with minimal prompt engineering, and its conversational interface allows for quick visual refinement. And OpenAI's Playground allows you to mix and match images and make edits to previous refinements and incorporate ingredients and so forth. It's a lot more powerful than ChatGPT. And you get to specify the output dimensions, resolution, and quality and so forth of the image through dropdowns. Video generation. We're going to use Google VO3, used for its high single-shot quality and native audio generation, which simplifies production by creating video and ambient sound all in one step. For soundtrack generation, let's use Udio. We'll use this to quickly create custom catchy soundtracks. This tool balances ease of use with a manual mode for more control, allowing for the creation of viral style audio that's more unique than stock music. And then the final assembly will be in CapCut. Optionally, you can choose CapCut, which is a very popular, really easy to use video editing tool compared to things like DaVinci Resolve and the Adobe tools. CapCut is simpler. I personally use Descript. I've mentioned that plenty in the past. I like Descript. It was built firstly for podcasters, but they built out the video tooling over time. But CapCut is a lot more popular out there in workflows in the wild, and so I'm mentioning it here. It's the standard video editor for short form content. It was free. I think they started monetizing it pretty heavily. It's cross-platform, and it has a really intuitive interface with effects and text styles designed for TikTok and Reels. Okay, the production stage, character and scene concept. You're going to select a tool, GPT-4o, via the OpenAI Playground. And its strengths for the prosumer are strong prompt adherence, text rendering, and conversational refinement. And the rationale is that it delivers predictable visuals with minimal iteration. Good for brand work. The production stage for the video generation is VO3. Its strengths are high single shot quality, integrated audio generation, and the rationale is that it simplifies production by combining video and ambient sound. For the music and soundtrack is Udio for its fast generation, genre flexibility, and manual mode for hooks. It gives you a little bit more control than Suno if you want to implement some modifications to the audio before integrating it into your video. Or if just simplicity is key and you just want to track, you could use Suno. So Udio will help you create viral style audio that stands out. And then the production stage for the final edit and assembly, a popular choice is CapCut, but you can use whatever you use if you already have a favorite. But CapCut has an intuitive UI, it's cross-platform, and it has built-in social media text and effects. And it's an industry standard for Reels and TikToks. Here is the workflow. You're going to create a character sheet with GPT-4o. So to ensure visual consistency, you're going to start by creating a set of reference images that define your character. You're going to write what's called a locking prompt, L-O-C-K-I-N-G, a locking prompt. You create a detailed prompt that defines the character's unchangeable features, like their facial structure or eye color, and variable features like their clothing and expression. For example, a locking prompt might look like this: a photorealistic headshot of Aya, a 25-year-old Japanese woman with a sharp jawline, intelligent dark brown eyes, and a small beauty mark under her left eye, and short asymmetrical black hair with a single streak of electric blue. She's wearing a minimalist gray turtleneck sweater. The background is a solid neutral gray. Professional studio lighting. Subject has a neutral expression, 8K, hyper-detailed, sharp focus. Step 2 is you'll generate the main image. Use the locking prompt in GPT-4o to generate the primary front-facing image of this character. Front-facing, because we'll iterate on that. Step 3, refine with conversational prompts. So use GPT-4o's conversational memory to create variations. You'll click the edit this photo in the OpenAI playground. There's various buttons on each generated image. And then you can use a follow-up prompt like, now using this exact same character, show her from a 3/4 angle, looking slightly off camera with a small confident smile. And then you'll do it again. For the next shot, keep the character identical, but have her look surprised, with her hand partially covering her mouth. Keep the studio lighting in gray background. And then step 4 is assemble a character sheet. So you'll collect 3 to 5 of these images. And this set will be used as the source material for all video generations to ensure consistency. Now, there is a kind of step 5 in this process. The GPT-4o model, whether ChatGPT.com or Playground, outputs a 3:2 or a 2:3 layout image. That 3:2 means landscape, and the 2:3 is portrait. So 3 pixels to every 2 pixel. So it's wide or it's tall. Unfortunately, VO3 uses 16:9 or 9:16. And these are the standard dimensions for phones, for example. It's a widescreen landscape or portrait layouts. And you can't control that. Even through OpenAI's API, you cannot get a 16:9. So you're going to have to figure out a way to get this in the dimensions that VO3 likes, because when you import these photos as frames for your clip, VO3 will detect that the resolution is off, and it will have you crop it. And what you'll see is very thick black boundaries on the left and right of your image. And you don't want to just zoom it all the way out and include the black borders. VO3 won't fill those in. It won't outpaint them. It will use your image as is for the scene. It will assume that you wanted those black borders, and it will keep the animation constrained within the visible window. So you have a few options. The easiest is to actually crop it in the VO3 frame editor, Just zoom it in to a good visible area of the character and the scene. And if that doesn't give you the results you want, you can use in your text to video prompt that the camera zooms out in short order. Or when generating the images, you can specify to GPT-4o that the character is zoomed out already. The character is in the center and far away, so that when you crop it in VO3, you have a lot of wiggle room to work with. Those will be your easiest options. Work within the constraints of the cropping tool of VO3 and get a little clever there. Or you can use an outpainting tool if you already have and know a good image editing software suite like Adobe Photoshop. You could use something like Firefly to outpaint the image to the specified resolution. Or you can start to get your hands dirty with Stable Diffusion in case you ever think you might use Stable Diffusion after you learn a little bit more about it by the end of this episode. If you think you might ever end up playing with Stable Diffusion, you might as well spend the time now to learn it a little bit. You can use Automatic 1111 instead of ComfyUI for simplicity if all you want is outpainting, so you don't have to learn the whole node-based pipeline workflow system. Or if all of this is too much, you can just swap out GPT-4o in this workflow with Midjourney in the next workflow. Midjourney can output 16:9 and 9:16 layouts. You'll just have to learn a little bit more the ropes because Midjourney is a bit more advanced than GPT-4o is in terms of achieving strong prompt adherence. But there's merit to using Midjourney instead of GPT-4o because there's a whole system of tools inside of it for creating character sheets with strong character consistency. So those are your options for getting the right resolution from the export of GPT-4o to VO3. Either A, be clever and work within the confines of the crop system. B, use an outpainting tool like Photoshop with Firefly or Stable Diffusion with Automatic 1111, or C, don't use GPT-4o, step up your game and use Midjourney instead. And you'll learn the Midjourney character sheet creation steps in the next workflow. Okay, back to the workflow. We have our character sheet, 3 to 5 of these character images. So step 2 of this workflow is to use a high quality chaining method in VO3. This technique creates a video longer than 8 seconds while maintaining VO3's highest quality model, VO3 quality it's called. It uses the final frame of one clip as the starting image for the next. Step 1, generate clip 1. So in VO3, select the image to video option. Upload the main image of Aya from your character sheet. Step 2, write the prompt for clip 1. Describe the initial action. So here's an example prompt. A photorealistic video of Aya. She is sitting in a modern minimalist cafe. She looks directly at the camera, then turns her head to look out a large window at a rainy city street. The camera performs a slow, subtle push-in on her face. Include the ambient sounds of rain against the window and the soft murmur of a cafe. You'll notice that these prompts are particular. They're nuanced. Again, go to the show notes on my website to get the prompt guide for images and videos. Each tool has their own nuances. Step 3, extract the final frame. After the clip generates, pause on the very last frame and take a high-resolution screenshot or use a frame-saving feature. Step 4, generate clip 2. Start a new generation. Upload the final frame of clip 1 as the source image. This creates a perfect visual continuity. Step 5, write the prompt for clip 2, the this then that method. Write a prompt that continues the action sequentially. This is the most effective prompting method for VO3. It's known as the this then that method. The prompt looks like this. Continuing from this exact moment, Aya turns her head back from the window to face forward. A look of sudden realization crosses her face. She picks up a white ceramic coffee mug from the table in front of her and brings it to her lips. The camera remains steady. And then step 6 is you continue this process. Generate clip, extract final frame, use the frame as input for the next clip until you reach your desired video length, And this method bypasses Video 3's lower quality internal sequencing tools. Now, I should mention, Veo 3 was only recently released. I'm sure very soon here that they're going to enable the Veo 3 quality model for extending clips and ingredients to frame and first and last frame. But as it stands, this is going to give you the best results, this workflow. Now, you will see on the internet, people are trying to figure out how to maintain consistency. They're using these really hacky workarounds where they are generating an image that they like and then having ChatGPT describe that image in excruciating detail, and then having ChatGPT describe a variation of that image in excruciating detail, and then only using text to video to generate each clip. And that workflow is, well, one, you're going to have bad results. You're going to get character inconsistency. The fidelity of conversion of text to video is not going to maintain the exactitude of the character you have in mind. So you really want to start with images, not text. And two, and this is a huge problem, Veo 3's credit-based system is extremely valuable. You can create image clips with the Pro tier or the Ultra tier. And depending on your goals and your use cases, you really want to conserve those credits and you don't want to make accidents. You don't want to throw away 5 bad clips for every 1 keeper. So starting with an image means you know exactly what you're signing up for, and all that remains is a strong prompt for the animation of that image. And image generation is cheap. So if you have to iterate on the first frame, 10 times before you get what you want, that's fine. That's inexpensive and it's fast. But you do not want to have to iterate over and over and over on video clips in Veo 3 until you get the one you want. So do me a favor, and if you see anybody linking out these tutorials on how to maintain character consistency through just text to video chaining, link this episode for me because they're hurting themselves and I want to set them straight. Okay, back to the workflow. Step 3, create a soundtrack with Udio. Create a custom high-quality music track for your video. Step 1, activate the manual mode. Use Udio's manual mode to prevent the AI from rewriting your prompt. Step 2 is use a structured prompt. Use tags to define musical elements. An example prompt would be tag genre, lo-fi hip-hop chill wave, tag mood, melancholy, pensive, hopeful, rainy days, and so forth. I guess I need to generate a prompt guide for Udio and Suno. I guess I'll do that. Hopefully I'll have it up by the time you check out the show notes. Otherwise, just look it up online. Step 3, generate and extend. Create a 33-second clip, choose the best variation, and use the extend feature to add an intro and an outro, or to generate more sections to reach your desired length. For songs with lyrics, write them directly into the interface and use tags like verse and chorus to structure the song. And then download the track as a final audio file. Or if all of that sounds like too much, you could use Suno, which is generally better at quick results, and just ask for a song, and it'll give you a song. Step 4, assemble and polish in CapCut. CapCut. Combine all assets into a final video. Step 1, import the assets. Open CapCut and import your Veo 3 video clips and the Udio soundtrack. Step 2, assemble the timeline. Place the video clips on the timeline in order, and the cuts should be seamless. If needed, use short 2 to 4 frame cross dissolve to smooth any minor jumps, because the end of one frame and the beginning of the next frame clips in Veo 3 might not be pixel perfect. So you might want a 2 to 4 second frame cross dissolve to smooth the jumps. Step 3, mix the audio. Place the Udio music track on an audio layer. Layer the volume of the Veo 3 clip's native ambient sound so that it sits under the music, providing texture without overpowering the soundtrack. Step 4, add text and captions. Use the text tool for branding or calls to action. Use the auto captions feature to generate subtitles, which is important for viewer retention on platforms where users watch with sound off. If you're the persona I'm describing who generates TikTok and YouTube Shorts videos, you probably already know that. But if you haven't heard that before, you want captions actually baked into your videos, not auto-generated by Instagram or YouTube Shorts. You want them baked into your video. And CapCut can do this for you. And then finally, number 5 is export the final video into a 9:16 aspect ratio at 1080 by 1920 resolution, 24 or 30 frames per second. And what I don't have here is that Veo 3 currently only supports 16:9 exports of MP4 files. It can only generate landscaped videos. You cannot generate portrait videos. Again, July 13th, 2025. This may change shortly. In fact, I know it will change shortly because YouTube has announced that they are going to integrate Veo 3 into the YouTube Shorts platform soon. But they clearly have to get over some sort of a technical hurdle. They need to make a version of Veo 3 that has a 9:16 output head in the neural network. You can't just generate any dimension output from image and video generators. It has to be a version of the model fine-tuned with a specific dimension head, or a super model that has a multi-headed output layer where some gating technique in the flow of the neural network will decide which head to use. So when you convert this video to a short or a reel, you're going to want it in 9:16. That's what those platforms expect. And so you'll either zoom in or you'll just have it squashed into the center of the frame and use your branding text and your captions to fill in the black zones, or just Google how to convert a landscape video to a portrait video. There's techniques, they're always imperfect naturally, pros and cons to different techniques. So find one that works for you. There we go, workflow 1. Now, workflow 2, the indie filmmaker workflow. By the way, if I seem out of breath in this episode, it's because I'm recording it at a treadmill desk. Aristotle, Nietzsche, Kant, and Thoreau all believed walking was essential to thinking. Nietzsche said only thoughts reached by walking have value. So I use a walking desk while I study, record, edit, or work. It improves focus, energy, alertness, and mood by increasing blood flow and endorphins. You should try one too. Meet your fitness goals while you study machine learning or work on your ML projects. See a link to my favorite walking desk setup at ocdevel.com/walk. That's ocdevel.com. Workflow 2, the indie filmmaker workflow, a hybrid approach for narrative shorts. This workflow is for creators making narrative short films, 1 to 5 minutes. The focus is on storytelling, character consistency, and a cinematic look. This requires managing more technical complexity than the previous workflow. The challenge is that no single video model excels at all types of shots. For example, dialogue, action, and establishing shots. The solution is a potential hybrid pipeline that uses specialized tools for each task. So for image generation, we're going to use Midjourney V7. Midjourney is chosen for creating the film's visual foundation. It has these flags, these parameters, --CREF, CREF for character reference, and --SREF or SREF for style reference. These parameters are used to establish a consistent character and cinematic look that can be used as a master reference across all other tools. So you have a lot more control about maintaining character and style consistency with Midjourney than you do with GPT-4o. Midjourney really shines at coming up with a character sheet or a palette. It's really good at wrangling consistency. And so you might consider using it for the previous workflow. I just wanted to give you like a real easy nuts to bolts workflow in the previous step. For video generation, we're going to use Kling, K-L-I-N-G, which is used for all dialogue scenes due to its high quality lip syncing and the ability to render realistic characters with plausible physics and micro expressions. Kling is really good at characters specifically. So if anytime you have two people chatting or an alien and a Bigfoot chatting, then Kling will be your guy. Runway Gen 4 is used for all other shots like establishing and action and B-roll. Its director mode offers precise camera controls like pan and tilt and zoom, and a multi-motion brush for adding localized motion. Now, VO3, Kling, and Runway are all viable video generation tools and video editing tools in this workflow. I'm going to use Kling and Runway here so that you get a bit of variety and you can see when and why you might use one or the other. But you can use one tool or you can use all three tools. It's up to you. Whatever strikes your fancy, by the end of this workflow, you should have a good sense of where each tool shines. VO3 is great at giving you an all-in-one video, voice and action, and prompt adherence. Kling is good at characters especially, and dialogue and lip syncing. And Runway Gen 4 is great at scene control and camera control and action sequences. So mix and match them at your leisure. Now, voice and dialogue, we're going to use 11 Labs. 11 Labs is used to generate very high quality, emotive, synthetic voices that can be convincingly synced in a video. If you have not heard 11 Labs text-to-speech voices yet, I encourage you to look them up. 11, E-L-E-V-E-N Labs. Look them up and listen to the voices. They are nuts, out of this world. And they're getting better and better and better. This is their bread and butter, and they're really taking the stage. They're the VO3 of voice. But there's great open source alternatives. Kokoro is my favorite. And then for the final assembly, color and finishing, you might use DaVinci Resolve. In this workflow, we're picking DaVinci Resolve over Adobe Premiere Pro because the powerful free version and the one-time purchase for the studio version are more economical. So if you're on a budget and you want a bit more simplicity than Premiere Pro, you might choose DaVinci Resolve. It's very, very popular on the internet and in these workflows. I see it all the time. DaVinci Resolve. It offers better performance with demanding codecs and integrates a top-tier color grading suite and node-based VFX environment called Fusion, F-U-S-I-O-N, in one application. So a bit of a breakdown. For character and world design, the tool will be Midjourney V7. Its strengths for narrative are the character and style reference, --C-ref and --S-ref. Its cinematic quality. It creates a master visual blueprint for consistency across all tools. Dialogue scenes. We're going to pick Kling, K-L-I-N-G. Its strengths for narrative are superior lip sync and high fidelity character realism and physics simulation. It's essential for believable dialogue scenes. Cinematic B-roll and action. We're going to choose Runway Gen 7. Its strengths are advanced camera controls, multi-motion brush, director mode. It provides creative control over non-dialogue shots. For voice generation, we'll choose 11 Labs. It has high emotional fidelity, voice cloning, and natural cadence. It delivers performances that can be convincingly synced. For edit, color, and finish, we will choose DaVinci Resolve. It's an all-in-one suite for edit, color, and fusion. It has good performance and good cost. It is a professional non-subscription editor with industry best color tools. All right, step 1, create a visual foundation in Midjourney. Establish the film's visual language by creating a master set of reference images for the main character and aesthetic. Here's the process. Step 1, generate the hero character image, H-E-R-O. That's the main character that we're going to be working from going forward. Create a single definitive image of a main character using a cinematic prompt. The prompt looks like this. A cinematic film still, a weary male detective, Jack, mid-40s, unshaven with a 5 o'clock shadow, tired eyes, wearing a rumpled brown trench coat, standing on a rain-slicked, neon-lit street in Tokyo at night. Photorealistic, anamorphic lens flare, 35mm film grain, moody, noir aesthetic, --AR 16:9. The --AR is for aspect ratio. And --style raw, --V7. Again, ocdevel.com for the prompt guides. Aspect ratio, that was the word I've been looking for. I keep saying resolution and layout. Aspect ratio. Step 2, establish a character reference with --C ref. Get the URL of the hero image. Use it with the --C ref parameter to generate new images of the same character in different poses while locking in their features. So --C ref uses a URL to my best understanding. So if you already have an image you want to use as your hero, you'll want to put it somewhere online that you can reference as a URL for your prompts. Example prompt, a cinematic film still of the same man sitting in a dimly lit ramen bar, looking at a case file on the counter, --C ref, the URL, --CW100 --V7. And the --CW, which is character weight parameter of 0 to 100, this controls how closely the new image matches that reference. So if you use 100, that will maintain maximum consistency for character consistency. Step 3, establish a style reference with --S ref. Use the same hero image URL with the S ref parameter to generate images that share the original visual style, so color, lighting, and mood, without including the actual character. Example prompt, cinematic film still, an empty, rain-slicked alleyway at night in Tokyo, neon signs reflecting in the puddles of the ground, --S ref, the URL, --SW 800. The SW parameter, style weight, controls the strength of the style transfer. Step 4, create a reference set. Generate a shot list of 5 to 10 still images, close-ups, medium shots, establishing shots, and so forth. This visual guide will be used in Kling and Runway to maintain consistency. So you can see you have a lot more control over your character sheet for character consistency. Okay, step 2 of the workflow. Create dialogue scenes with the 11 Labs to Kling pipeline. 11 Labs to Kling pipeline. To get the best lip sync, generate the audio and video separately and then combine them. Generating video from a prompt that includes dialogue often results in a poor lip sync in Kling. So step 1 is generate your voice track in 11 Labs. Write or upload your dialogue script to 11 Labs. Choose a pre-made voice or clone a custom one. Adjust stability and clarity sliders for natural emotive performance. Download the final dialogue as a high-quality audio file. And by the way, 11 Labs has tons of voices because you can submit your own voice and you can get paid for every time your voice is used in this kind of a workflow. People are making about like $300 a month. So if you ever want to sell your voice, you can sell them to 11 Labs. Step 2, generate a neutral video in Kling. In Kling's image to video function, upload a close-up or a medium shot of your character from the Midjourney reference set. Write a prompt describing the character's emotion and the scene, but explicitly state that they are not speaking. For example, his mouth is closed. This prevents random mouth movements. Here's an example prompt. A cinematic close-up of a detective, Jack. He listens intently to someone off-screen. His expression is serious and thoughtful. His mouth is closed. The scene is dimly lit, subtle ambient motion. Generate a 5 to 10 second clip. Step 3, apply the lip sync in Kling. Select the neutral video that you just generated. Use the lip sync or add audio feature in Kling. Upload the corresponding dialogue track from 11 Labs and Kling will process the video, mapping the audio phonemes to the character's face to create a highly accurate lip-synced performance. Next step in the workflow, create a cinematic B-roll with Runway Gen 4. Use Runway's advanced tools for scenes without dialogue. Here's the process. Step 1, use advanced camera control. To create a specific camera move, upload a reference image from your Midjourney set to Runway. Use the director mode camera controls to set a precise dolly or pan or any of those movements. This gives you more deterministic control than text-based motion prompts. Step 2, use the multi-motion brush. This tool adds subtle life to static shots. Upload a static image, like a car parked on a street. Use up to 5 brushes to animate different parts of the image independently. Like brush 1 might paint over tree leaves and set a low ambient motion to simulate a breeze. Brush 2 might paint over a puddle and set a different subtle ambient motion for a ripple effect. And brush 3 might paint over distant trees with a very low ambient motion to create a parallax effect. This technique adds layers of realism and production value. Step 3 is maintain consistency. Always use a corresponding image from your Midjourney reference set as the source for every shot generated in Runway. And then the final step is assemble and color grade in DaVinci Resolve. So let's combine all assets and apply a professional finish. The process is step 1, import your assets into DaVinci Resolve. All the generated assets, lip-synced clips from Kling, B-roll from Runway, high-quality audio from 11 Labs, and any music or sound effects that you want. Step 2 is edit the narrative. Assemble the clips on the edit page timeline. Place the clean audio tracks from 11 Labs on separate audio layers, ensuring they are perfectly synchronized. Step 3 is perform a professional color grade. On the color page, use DaVinci Resolve's node-based tools and scopes to match the color and contrast of clips from Kling and Runway. Once shots are matched, apply a final creative look. For a noir film, you might desaturate colors, crush blacks, and add a cool blue tint to the shadows. And then finally, step 4, export. On the deliver page, choose an export preset. A high bitrate H.264 or H.265 is good for web distribution, while a professional codec like Apple ProRes is better for festival submissions or archival. Okay, workflow number 3. Quick question. At any point did you think, if Tyler's recording this at a walking desk, why don't I hear the treadmill? Can you hear the treadmill now? This is what my raw recordings sound like. I use Descript to magically improve my audio quality. It's a recording studio that uses AI to enhance audio and video and reduce mundane editing tasks like removing filler words and retakes. If you're a content creator, try it out at ocdevel.com/creator. Okay, workflow number 3. Are you ready? Buckle up, my friends. This one's very complex. If you really only care about workflows 1 or 2, you could probably skip this. But if you want to know how to do the really advanced stuff, maybe this will be handy for you. Stable Diffusion is a very powerful and very useful tool. So if you ever think you might consider using more advanced techniques in the future, then listen on. This is workflow number 3, the professional studio workflow. You want full control with ComfyUI and your video editing software of choice. So this workflow is for professional visual effects artists and studios working on high-budget products. These are professionals, Hollywood people. The goals are complete control over every pixel, photorealistic quality, perfect actor likeness, and integration into a standard non-destructive visual effects pipeline. Another possible goal here is control on cost, because you're going to be running this on your own hardware a fleet of GPUs in a node-based pipeline where using open source projects rather than necessarily, although you could, use back-end APIs like OpenAI or Google Vertex or 11 Labs. So you control not only every step and the quality and the consistency, but also the cost. The challenge with mainstream tools like VO, Kling, and Runway is that they are black boxes. They output compressed formats like MP4s, which are unsuitable for professional compositing, and this workflow avoids them. Instead, we're going to use a modular open source pipeline in ComfyUI, and this approach treats AI as a controllable render engine, outputting multi-layer open EXR files that are composited in a professional VFX application like DaVinci Resolve's Fusion page. And we're going to use DaVinci Resolve for this example yet again, but if you are an Adobe person, you'll use whatever tool you want as the final compositing stage. The tool chain goes like this. For the core engine, we'll use the Stable Diffusion ecosystem. This is the only platform with the necessary open modular architecture. This workflow uses models like Stable Diffusion 3 or Flux, FLUX, within the ComfyUI interface. We'll use control layers. We'll call this the stack. Precision is achieved by layering multiple independent controls. Number one of the control layer is custom LoRa training. A LoRa, a low-rank adaptation layer, is trained on an actor's face or costume to embed their specific visual data, ensuring true likeness. Number two, multiple control nets. A stack of control nets dictates scene structure. For example, open pose controls the character's skeleton. A depth map controls 3D layout, and line art preserves details. Number three, IP adapter face ID. After the LoRa and control nets, a IP adapter face ID, specifically the plus V2 model, is applied as a final reinforcement layer to lock in facial identity and prevent drift during animation. And again, if a lot of this is overwhelming, listen to 2 episodes back on the image generation episode and go to the podcast show notes page and you can see this entire workflow laid out and you can click the links that have more details on these various aspects. Number 4 is animate diff and motion LoRa's. So instead of text prompts for motion, this workflow is going to use the animate diff module with specific motion LoRa's trained on precise camera movements like pan left and dolly zoom for deterministic controllable cinematography. And then visual effects compositing in DaVinci Resolve's Fusion page. Resolve 20 or later versions have strong native support for multi-layer EXR compositing in the Fusion page. Its node-based architecture is ideal for this kind of a pipeline. So, quick breakdown. For perfect actor likeness, we're going to use custom LoRa training. This fine-tunes a model on a specific actor's face or costume, and it achieves true contract-level likeness for commercial work. For bulletproof identity lock, we're going to use IP adapter face ID plus version 2. IP adapter -face ID plus V2. This reinforces facial identity on every frame post LoRa, the final quality check to prevent identity drift in animation. For precise pose and scene layout, we're going to use multiple control nets, like a pose map and depth map. This conditions generation on skeletal pose and 3D depth. This allows artists to direct the scene with precision. For specific camera movement, we're going to use animate diff and motion LoRa's. This applies predefined motion vectors for pans, dollies, and zooms. This replaces vague motion prompts with controllable camera work. For professional post-production, we'll use a multi-layer EXR export This renders separate passes like diffusion, specular, and matte into one file. And this enables non-destructive editing of the final image. And then for the final shot assembly, we will use DaVinci Resolve with the Fusion feature, which is a node-based compositing of EXR layers. And it integrates AI assets into a standard VFX pipeline. And again, you may prefer Final Cut Pro or Premiere Pro. You pick your own editing software. If you're this far in the episode, you definitely have a software of choice. You go ahead and stick with that. Okay, here we go. Step 1 in this workflow is to train a character LoRa in ComfyUI. To achieve an identical likeness, a custom LoRa must be trained on the subject. The process goes like this. Step 1, prepare the dataset. Gather 15 to 30 high-quality images of your subject in various lighting, expressions, and angles. This could be a real person that you take photos of, and you'll crop and resize all the images to a consistent square resolution, 1024 by 1024. Step 2, automate captioning. Training images must be captioned with descriptions that do not include the trigger word you will use to activate the LoRa. In ComfyUI, use a workflow with a blip captioning node to automatically generate a descriptive.txt file for each image. Step 3, train the LoRa in ComfyUI. Use a dedicated LoRa training workflow like the one in the ComfyUI Flux Trainer, custom node pack by Kijai, Kijai, a user on GitHub has an example for this. Configure the trainer node. The image path will point to the image dataset directory. The trigger word, you define a unique token to activate the LoRa, for example, character_OHWX. The output name your LoRa file, like myCharacter_V1. The training parameters, set epochs, which are the number of training iterations over the dataset, between 50 and 100, and adjust the learning rate and network dimensions and alpha as needed. And then you'll execute training. You'll queue the prompt, and the final .safe tensors will be saved to your ComfyUI /models/LoRa's folder ready for use. So you're training a neural network with a custom data set. Because I have limited time, I'm just going to speed run you through all this so you get a sense of how everything strings together, but ultimately you'll want to watch a video tutorial on the real step-by-step. Step 2 is build the ComfyUI video pipeline. This is the core generation process, structured as a logical node graph where each control system feeds into the next. Here's the node chain walkthrough. 1, loaders. Load all the assets first. You'll have nodes that do checkpoint loading. They load the base model like flux1-dev-fp8.safe tensors. You'll have a loader node for the LoRa. This will load your custom LoRa, myCharacter_V1.safe tensors. And then you'll have a node for encoding the prompt, the clip text encoder, CLIP. We'll talk about clip in the MLG episode on diffusion models. Create 2 nodes, one for the positive prompt, which must include your trigger word, for example, photograph of character_OHWX, and one for the negative prompt. 2, the control net stack. You'll chain multiple apply control net nodes together to define the scene's physical structure. The conditioning output from the prompt node is fed into the first apply control net node. This node is conditioned on a reference pose image using a loaded control net file and a preprocessor like DW preprocessor. The conditioning output of this first node is then piped into a second apply control net node, which could be conditioned on a depth map. This layering creates a highly specific structural guide. 3, IP adapter face ID. Pipe the final conditioning output from the control net stack into an IP adapter face ID node. This node also takes a clean reference photo of the actor's face and uses the IP adapter face ID plus v2 file model to lock the facial identity before animation. 4. Animate diff. Pass the fully conditioned model to an animate diff loader node. Load a base motion model checkpoint file and a specific motion LoRa loader checkpoint file to apply a controllable camera motion. 5. K-sampler. Feed the final conditioned model prompts and an empty latent image node into the K-sampler to generate the image sequence. 6. Variational autoencoder decode and output. Pass the output latent from the K-sampler to a variational autoencoder decode node to convert it into pixel space, and pipe the final image output to the EXR saving nodes. Step 3 of the workflow is export multi-layer EXR sequences for visual effects. Render the output as a sequence of open EXR files which contain multiple layers of data for post-production. The process is: Step 1, isolate render passes. To separate elements for compositing, either run the generation multiple times with slight changes, for example, rendering once with a green screen background to create a character matte, or use custom nodes to split the generation into passes like diffuse, specular, and mask in one workflow. Step 2 is use a dedicated Save EXR node. Pipe the final image output from the variational autoencoder's decode node into a saving node like Save EXR from the ComfyUI HQ image save node pack. You'll specify a file path, set an image sequence path. The compression, choose lossless compression, PIZ or zip. sRGB to linear, you'll set to true. Professional VFX pipelines use a linear color space for correct lighting math. And a bit depth, you'll set to 32-bit float to preserve maximum color and luminance data. That's HDR. And then step 4 of the workflow is to composite the shot into DaVinci Resolve Fusion. Assemble the AI-generated EXR sequence into a final shot. The process is: Step 1, import the EXR sequence in Resolve's Fusion page, add a loader or a media in node, and import the EXR sequence. Step 2 is access layers. With Resolve 20 and above, a single media in node can contain all render passes. Connect a tool, for example, color corrector, to the media in node, then use the inspector's drop-down menu to select which layer, diffuse, specular, or matte, the tool should affect. Step 3 is reassemble the shot with nodes. Use a channel booleans node to extract the character matte. Pipe the diffuse pass into its own color corrector node to adjust colors. Pipe the specular pass into a separate color corrector to tweak highlights. Combine them with a merge node set to plus or add mode. Use the extracted character matte as a mask for other effects, like applying a glow only to the character. And step 4 is final integration. Merge the reassembled AI character over a background plate. Add final touches like camera shake, lens distortion, and a unifying color grade to the entire composite. Connect the final node to the media out node to send the finished shot to the Resolve timeline. And all this provides full creative control and integrates generative assets into a standard professional VFX pipeline. And I apologize for sort of speedrun blasting through workflow 3. It's not really something you can do in podcast form. So you'll want to look at the detailed steps on the show notes and click through the links to find some video tutorials on actually stringing these things together. But the name of the game is learning ComfyUI and its various advanced nodes, training your own custom LoRa on the characters you want in your scenes, and control net poses to put them into various positions, and animate diff to animate or interpolate the keyframes. And then finally open EXR so that you can edit different parts of the final output in isolation all together within your video editing suite. So those are the workflows, and And if you like this podcast series, now would be the time to help me by sharing this episode. I think this episode has the most virality potential due to the popularity of AI video generation right now. And people are looking for consistency techniques, especially with VO3. And they're coming up with all sorts of oddball solutions using ChatGPT. So I could use the help by you sharing this episode out. I think if ever there was a specific episode that would boost traffic to the podcast series, it would be this one. Thanks for listening, and I'll see you in the next episode where I will describe the technical underpinnings of these things like LoRa's, control nets, diffusion models, variational autoencoders, all of the words that you heard in Workflow 3. Once I release that, you may want to listen to that episode and then come back and then listen to Workflow 3 again. Also, I'm available for part-time work, so if you need a consultant or a contractor, go to ocdevel.com for my professional experience and contact information. Let's work together. You've been listening to Machine Learning Guide, and I'm your host, Tyler Ranelli. MLG teaches the fundamentals of machine learning and artificial intelligence. It covers intuition, models, math, languages, frameworks, and more. It's a start-to-finish audio overview of machine learning principles. Then for topics needing more depth or which are best learned visually, I provide a syllabus of resources at ocdevel.com/MLG. That's OCDEVEL.com. You'll notice that episode titles start with either MLG or MLA. G for guide teaches theory and fundamentals, where A for applied teaches industry and practical tools. You can listen to either or both depending on your goals. If you want to support the show, like and subscribe in your podcatcher, whether iTunes, Spotify, or YouTube.